All right, so let's move on to three-phase voltage source converter. So if you see in single-phase voltage source converter, we talked about the basic principle of operation and the modulation. In one of the video, we discussed that there are essentially three components. One is the control, other one is modulation, and the third is the power circuit in any power electronic system. So in this course, which is an introductory course, we are not discussing about the control, but maybe at a later time we would talk about control. But at this stage, we are mainly focusing on the operation of the circuit and the modulation. So with that, let us move on to three-phase voltage source converters. Uh, so why do we need three-phase voltage source converters if we have single-phase voltage source converters, right? That could be one of the thought. So if you see there are a lot of advantages of having a three-phase inverter or a three-phase rectifier instead of a single-phase inverter or a single-phase rectifier. One of the advantage, if you see, is utilization of a three-wire system. What does it mean? Let's say you have a single phase supply, then you have two wires, one is phase and neutral, right? And the current flowing through in this circuit is IRMS, right? And similarly, if you have another phase, so let's say this is A phase, similarly you have another phase which is B phase, and you have C phase, right? Considering this is a balanced system, you can connect only these 3 points to the load, and that would still be able to supply the same amount of power, and you can save on these 3 wires of corresponding to each neutral. So you see, effectively the reason is because if these wires connect together, then the addition of the neutral current becomes equal to 0 if the system is balanced. So essentially there is no neutral current, so you can very well remove it also if system is balanced, right? So going for this 3-wire system where you do not have a neutral wire, you only have A phase wire, B phase wire and C phase wire, you can save on the conductor, right? That is the reason why most of the transmission of the power which happens using AC system happens using 3-wire system and not 4-wire, right? Or even if you require a 4th wire just to take care of the unbalancing, you can use a thinner wire. You don't have to use 3 times the wire of corresponding to each phase. So it really helps. So that is one of the motivation of using 3-phase voltage source converter. Very similar motivation. If you want to drive a load or if you want to connect it to the grid, whichever way you want to use the converter, you can use it you can use using 3-wire system, thereby saving on cost. The other advantage of using a 3-phase voltage source converter is the motor drive application. You do not have oscillations in torque. So oscillations or torque are missing. Reason being, again, if you see, we discussed about power. So power in a single phase circuit is nothing but a constant value plus an oscillatory value. If you add power from A phase, B phase and C phase, all the 3 phases, then you see that the net power becomes power A plus power B plus power C. These last 3 terms cancel out and you only have an average component. There is no oscillatory component. And because of that reason, you do not have any oscillations in torque if you are using this 3-phase converter to supply a motor, right? So if you have 3-phase converter and if you are supplying a motor, in that case the motor torque will not have oscillations of low frequency. On the other hand, if you supply using single phase motor, then this motor would have low frequency oscillations because the current would be going sinusoidal, the power would also be oscillating at 100 Hz. This is the second advantage, and the third advantage is kind of derived or very in continuation to the second advantage, and that is if you have a single phase inverter versus a 3-phase inverter, the DC capacitance requirement in a three-phase inverter is less, for the reason that in three-phase inverter, again, the total power is constant, and therefore you don't need large capacitance to supply the oscillatory component of the power, right? On the other hand, in this kind of rectifier system, let's say this is connected to AC system, so this is a rectifier system, right? You need large capacitor so as to minimize the ripple within a certain value, and that is again, so usually for low power it's convenient, it's three single phase systems are still used, right? But as you increase the power, three phase systems are much more popular. So that is the reason we need to study three phase voltage source converter. So how does the converter looks like? Let us just have a quick look at how would this three-phase voltage source converter, basic voltage source converter would look like. So you take a half bridge single phase converter, right? Take a half bridge single phase converter and connect another half bridge, connect another half bridge. That's it. This is your three-phase voltage source converter. You just connect three half bridges. You have outputs corresponding to each leg A, B, and C, which can connect to the load or which can connect to the grid, right? Depending on whether you want to operate it as a rectifier or do you want to operate it as an inverter and so on. So three-phase voltage source converter can be used in two particular fashion. The one which I am showing is nothing but a three-wire system. You see only three wires, right? So this is a three-phase voltage source, three-phase three-wire voltage source converter. You can very well, depending on the application, if you feel that there is going to be unbalance in the system and you require a neutral point, then you can also generate a neutral point, and that would become a three-phase four-wire voltage source converter. These are the two popular circuits. There are other circuits, there are other four-wire circuits also. But in this introductory course, we'll just focus on this basic circuit in terms of the principles. But with those basic principles learned, you should be able to apply to even more complex circuits. So that is what is expected in this course. So try to understand these basic principles, and then if you see a new inverter circuit, then you try to apply those basic principles to those new inverter circuit also and try to solve those. Okay, with going forward with these two circuits, three-phase three-wire and three-phase four-wire voltage source converter, let us see the different modulation schemes, right? Let us start with the fundamental modulation scheme in the next video.